Now, when you first approach this question, you question your life, okay? You question why are you existing in this world to do this question. You question your course and you question every single thing about everything, right? But chill. Shh. We will do it. So, the first thing when you come to a question which you do not understand or basically just gets blindfolded by impossibleness, calm down. Now, after you calm down, we just do steps at a time. And that's maths, right? Just steps. So prove that a product of an irrational number and a non-zero rational number is irrational. Now straight away, can I logically prove this, right? No, because to prove that it's irrational, my final answer obviously is going to be irrational, but I cannot basically rewrite irrational as a symbol, right? But rational I can, right? If I say what's a rational number, it can be written as a over b, where a and b are elements of integers. But if it's irrational, even though I can do this calculation, how can I prove it in my answer is irrational, because that can't be represented as anything. So when you're proving a final answer that's basically improvable, and there's no symbols that can represent it, we use something called proof by contradiction. And what is proof by contradiction, you may ask? Well, you assume the otherwise. So we're going to assume that this whole answer here to the statement is going to be rational. And if we prove that it's not rational some way mathematically, then obviously the next alternative will be it's irrational. So then you prove this whole thing. Okay, so after we chilled, which is now, let's do it. So prove the product of an irrational number. Now, an irrational number, we do not have a symbol for it, but let's call it x. And a non-zero rational number can be written as a over b. Now remember, this is saying non-zero because a rational number can be 0. And also, there's a restriction here. B can't be 0 because obviously it's undefined, but also a can't be 0. Because to get a 0 as an answer, which is a non-zero rational number, if the up is 0, and the bottom can be a number like 10 or whatever, it'll be 0, right? 0 divided by 10 is 0, 0 divided by 20 is 0. So a can't be 0, b can't be 0. Now we're proving that a number is rational. So rational can be represented as a number such as a over b. But when we're doing like proofs, we do not want to make two rational numbers the same, like a over b and this rational a over b. We'll just say this is m and n. Remember now, we made this rational, right? Because we need to prove it that it's not rational, then obviously it's irrational. But right now we're proving that it's rational. So right now, we need to say what we did, right? Because we can't just do this and expect people to just be like happy. Mathematicians will kill you. They literally kill you. So don't do that. So write what you did. So we said let x be rational, a rational number. So x is a rational. Now I'm not going to write the full word, but q is a rational number. And or you can write q is an element of integers, right? Because the rational number is an element of integers. Or you can say q is rational, whatever, long as it makes sense in your life, in the proof, right? Then we said a non-zero rational number. So I know it's non-zero rational number. Excuse my handwriting, like literally, like I can't read my own writing, to be honest with you. Is now a over b is rational, but a cannot be. So a cannot be 0, b cannot be 0, because I told you a cannot be 0 and b cannot be 0, because a cannot be 0 because it'll make it 0 as answer, and you do not want that. And obviously b can't be 0 because 0 makes it undefined. Now also you rewrite the statement saying that a rational number is also b. So you can say the second rational number, or you can just say also m over n. But m over n is a rational, so it doesn't have to be a non-zero rational. So you showed that you said that this rational is represented as m over n. This non-zero rational is a over b, where a cannot be 0 and b cannot be 0. Obviously you have to say my restriction, n can't be 0 because that will make it undefined, so I have to say restrictions. And basically we're done. We're done doing what we did now. But now let's prove it, the fun part. So do what they're telling you. So prove that the product of an irrational and non-zero rational number is irrational. Is rational. So do, okay? Product means times. So you must times the irrational by the non-zero rational. So we made the rational x. So x times non-zero rational we set to be a over b, which is equals to another rational number which is represented as m over n. Now you want x to be by itself. So x is equals to, so obviously it's going to be m over n divided by a over b, right? We're dividing both sides by a over b. So that will be m over b and, let's see, m over b and n over a. So that's basically division. Or you can just say times this by, so you can times this by b over a and this by b over a. Now why will this work? Well, b over a cancel out here, a cancel out there, so you're left with x and obviously mb times na. However you want to do it, right? But basically the most important part is we came to this answer. So this now, it's clearly not what is it called? It's not an irrational number. It's rational, because this is how we proved it. We said x is an irrational number, yeah, okay? But this is contradicting it, because this is rational. So if you said x is irrational over here and you made x to be irrational, you as a final answer is getting x to be rational, right? Because m over b, m times b over n over a, m and b are integers, n and a are integers. 5 over 2 over 3 over 2 are integers, right? At the end of the day, these are integers, like 3 times 5 over 9 times 2. The integers, they can be written as a fraction as a over b. So because this is a contradiction, okay, this has to be true, the original statement where the product of an irrational number and a zero rational number is irrational, because we made this rational, right? But the problem is we're getting this here, it's contradicting this. So whenever you get an answer that contradicts anything over here, the previous original statement will be true, because right now this whole statement which we made rational is false, which implies the other one is the true one. And that's how you get or answer this question.